Hello, here I am again with a very exciting question. What is this question is all about? It's a reaction pathways question. You know that we love reaction pathways because reaction pathways, in order to do reaction pathways question, you need to have a good idea about all the chemical or all the organic reaction. I hope that you have that knowledge. What's the time? Almost 4 o'clock. We are still going. All right. Let's have a look at this question. Now, if when you look at this question, you will see the diagram below shows the part of a possible reaction pathway for producing a compound which has a distinctly a fruity flavor. When you know when they say that there is a fruity odor, not flavor, fruity odor. So you know that this is the ester. So this is the ester. One of the unique property of a no one of the physical properties of a ester is they have distinctive odors, right? Sometimes they smell, sometimes they smell bad, sometimes they smell good, that sort of stuff. So this is a ester. If you are to make a ester, you know that you need to have two molecules, right? You need to have two molecules if you want to make ester. So you need to have two molecules if you want to make ester, man. Two molecules. What are those two molecules? Carboxylic acid and alcohol. Carboxylic acid and alcohol come together with the presence of concentrated sulfuric acid to form ester molecule and a water molecule. Condensation reaction, not polymerization, condensation reaction. All right. Now, then the X and either X or Y needs to be, X has to be either alcohol or a carboxylic acid, right? Likewise, we don't know which one is which. That's what we need to find out. But we know the X or Y has to be X and Y has to be carboxylic acid and alcohol. Is that right? So we need to sort it out which one is which. Now, by looking at the first reaction pathway, you are starting with a chloroalkane. So you are making a product W with chloroalkane. What sort of reaction chloroalkane can undergo? Substitution reaction. So we can make a alcohol easily. If this was an alcohol, we can oxidize into a carboxylic acid, right? Acid. We can oxidize into a carboxylic acid. I mean, yeah. So that seems like we can make acid. Okay, let's go to the reaction pathway 2. Oh, you got alkene. You are making a chloroalkane. Now, why cannot be a carboxylic acid? Why we cannot? There is no way we can convert a chloroalkane straight into a carboxylic acid, right? We never learn a reaction where we could convert a chloroalkane into a carboxylic acid. We never, because chloroalkane undergoes only substitution reaction, right? You remember that? So then, but we learn how to convert a chloroalkane into an alcohol. So we can easily convert into alcohol. So Y has to be an alcohol. That is how I know which one is which. All right. So you need to do bit of a reverse engineering to work that out. Right. Now, since we know, name the product. Since we know since we have a good idea about the whole process, now let's start looking into answering these questions. Name compound Y. Why? It has to be alcohol. So what's the alcohol? You add sodium hydroxide here. You are going to get what? Propan-2-ol. Look, this is the carbon. That OH is going to be that chlorine is going to be substituted by the OH, right? So in this case, it becomes compound Y is become propan-2-ol. Okay, is that clear to you? All right, propan-2-ol. You got that propan-2-ol right? All right, that's right. Compound Z. Z is what? Compound Z. Why is not it hiding? Okay, compound Z is is, before we start looking at propan-2-ol, we need to work out what we need to work out what the alcohol is. This is 2-chloroethane. This is 2-chloroethane. Then you can substitute that with, again, potassium or sodium hydroxide. Then this becomes ethanol. Okay. Ethanol, we can oxidize ethanol into ethanoic acid. So X has to be the ethanoic acid. ethanoic acid, right? Ethanoic acid. Mm-hmm. Ethanoic acid. Ethanoic acid. Now, propan-2-ol, name the compound Z. Oh, there was a bit of an issue here. What is the issue? Because we are making propanol. This is not propan-1-ol. This is propan-2-ol. Because, yeah, this is propan-2-ol. No, this is propan-2-ol, isn't it? Oh, what's going on here? So propan-2-ol, I mean, you can make an alcohol. You can make a, what I was meant to say, but you are not supposed to name this sort of esters. Yeah, because you are not supposed to name esters made up of secondary alcohol. We can specifically say you have to make only the what? Only the esters made up of primary alcohol. So this is a secondary alcohol. So you don't necessarily have to name this ester. You know what I mean? But you can make ester. That's not a problem. But you don't have to name them. So naming is not really part of our. Is it propyl ethanol? No, it is not propyl ethanol. Yes, propyl ethanol can be made using propan-1-ol. Yeah. The propan-1-ol. But here, according to this, you are only making. You cannot make propan-1-ol. You are making propan-2-ol. So you cannot name this ester, man. This question bad question. Vika says you don't have to name esters when they are made with secondary alcohol, only primary alcohol. Why are they asking? Stupid. Okay, so you don't have to name them, but we'll still have to make it, right? Because there's a school called Nostril. Nostril gave a question a couple of years ago. They gave you a secondary alcohol. Yeah. And they wanted you to make a ester, but they never asked you to name it. But what happened? Kids didn't want to make it because that's a secondary alcohol. That's a bit of a silly mistake, but we'll try to make the alcohol ester anyways. So what is our ester? Propan-2-ol. So, okay, let's draw this ester. Propan-2-ol is this. Propan-2-ol. So this is propan-2-ol, right? You don't have to name them. This is, you got CH3 here, you see that? And then you got ethanoic acid. You got ethanoic acid here. That's ethanoic acid. Is that clear to you? Then we make the ester here. CH3, 2, CH, then what? We'll start with the other way around, so let's make it easier. Okay, so CH3, CO, then O, yeah, O, because this is how OCH and CH3 too. That is the ester. You don't have to name them. No naming. Stupid. Okay, that's identify the catalyst that would be required in the reaction to produce Z. And the catalyst is concentrated H2SO4. So if you don't put a catalyst, this reaction would not happen. Concentrated sulfuric. So you can say it's H2SO4 liquid. That's also concentrated. Don't put aqueous here. All right. Okay, what's the next one? Name the byproduct of the reaction X and Y. X and Y is what? X and Y. What is X and Y? Oh, that is condensation reaction, acidification, water. D, E. And name the process of W to X. W to X is what? W to X. We know that ethanol to ethanoic acid, that is oxidation. W to X, ethanol to ethanoic acid, that is oxidation, right? Simple. Okay, what do you need to add to make that oxidation reaction happens? Acidified KMnO4, right? Acidified potassium permanganate or potassium dichromate. All right, that's done. There could be an intermediate product W to X. What is W to X? W to X? Yeah. What? Alcohol to carboxylic acid. There could be intermediate product from double states the homologous series that could be belongs to. Ah, okay. They are saying, remember, primary alcohol can get oxidized into what? Primary alcohol can get oxidized into what? Aldehyde. So that's what they are trying to say. However, if you add heat during the oxidation process, you are not going to get the aldehyde. You only going to get the carboxylic acid. But yeah, in this case, you have to make sure you add heat, but they can be, if there can be intermediate product, it has to be aldehyde. Yeah. So write aldehyde. It has to be the aldehyde. Okay. All right, that's done. G. What? Okay, primary alcohol. Primary alcohol. Now listen. Primary alcohol under mild condition get oxidized into aldehyde. What are mild condition? You have to have acidified potassium dichromate or potassium permanganate, but the mild condition is you must not add heat, right? Then you get the aldehyde. So if you add heat, what will happen? Aldehyde will become the carboxylic acid. That is what we want to happen here. We want the carboxylic acid. We don't want the aldehyde, because with the aldehyde and alcohol we cannot make the ester. Is that right? Okay. Hope you get that. Now what else I was meant to say? I was planning to say, if you have what? If you have a secondary alcohol, you don't get aldehyde, you get ketone. Ketone is not going to be further oxidized into carboxylic acid. So if you want to make a carboxylic acid, you need to have a primary alcohol, then the aldehyde. If you want to make into aldehyde, or you can straight away make it into a carboxylic acid. Secondary alcohol, ketone. Tertiary, no reaction. Okay. Then what do you have to do here? Let me get these things. I really don't like this thing. Okay. Aldehyde. Okay. G. Describe the experimental techniques that could be used to distinguish W and X. What is W? Man, I cannot remember all these things. W is alcohol. W, what comes after W? X is a carboxylic acid. Okay. Carboxylic acid, right? So how do you differentiate alcohol from a carboxylic acid? There are a lot of chemical reactions that you can do to differentiate alcohol from carboxylic acid. First one, add sodium carbonate. When you add sodium carbonate, acid X what would produce or will produce bubbles, which is carbon dioxide gas bubbles, right? But alcohol, there is no reaction with alcohol. Alcohol, no reaction. Now, okay, you know that carboxylic acid or any acid will react with sodium carbonate and produces carbon dioxide. So you see bubbles. Alcohol would not react with sodium carbonate. Okay. The other one is what? What's the other one? You can measure pH. pH of carboxylic acid will have very low pH compared to alcohol. pH is also correct. What else? Oh, what else? I'm just trying to remember. Okay, you can add potassium dichromate. Look, alcohol will undergo, in this case this is a primary alcohol, will undergo oxidation. Okay, if you put alcohol and carboxylic acid, alcohol will undergo oxidation with potassium permanganate or potassium dichromate, and that will change the color of the potassium permanganate from purple to colorless. Yeah, that's another reaction you can do. Acidified potassium permanganate, color changes. That is what oxidation is, right? So acidified potassium permanganate, alcohol, and you react with it, alcohol changes. There will be a color change. What is the color change? Purple to colorless. The potassium permanganate is purple. then it becomes Mn2 plus, which is colorless. All right, that's another one. What else could you do? Sodium carbonate, primary alcohol, acidified. Okay, you can also say boiling point. You know that. Which one is have a higher boiling point? Which one? Remember the boiling point? Alcohol and carboxylic acid? We discussed that in today's class as well. Both can make hydrogen bonds, so they have relatively higher boiling points. But when it comes to carboxylic acid, remember? Carboxylic acid, what are these? What are these? What are these? What are these? Dimer? Dimer? Because carboxylic acid, okay, like that. Carboxylic acid can make two hydrogen bonds with each other and they exist as dimers. Dimers are larger molecule which can make more dispersion forces. So carboxylic acid will have higher boiling point in compared to alcohol because of the formation of dimers. Alcohols would not produce dimers. You must have to you have to memorize that. Not memorizing. Yeah, you have to know that. Okay, boiling point of carboxylic acid. Carboxylic acid is higher than alcohol. Okay, higher than alcohol. Why? Due to presence of stronger intermolecular forces. Okay, that is due to formation of dimers. All right, man, we've done that. Last question. H state X or Z must more suitable. What? X and Z. What is X? I can remember. X and Z. Oh, yo, that's the easy question. Oh, I haven't put the. Okay, X and Z. X and Z. That is an easy question, isn't it? X is what? X is alcohol. Alcohol can make hydrogen bonds with water, so it's highly water soluble. Alcohol. So it's X is alcohol. We know that. So hydrogen bonds. Hydroxyl group can make hydrogen bond with water. Hydrogen H bond with water. Both polar. But the ester now look, ester hasn't got a hydrogen bonding hydrogen there. No, ester can only make dipole interaction. Okay. Okay, what's the answer? X should be more water soluble in water. X and Y. X because stronger hydrogen bond. Stronger hydrogen bonds. What is X? It's not alcohol. I made a mistake. Silly me. X is a carboxylic acid. Oh, sorry about that, man. X is a carboxylic acid. It's a carboxylic acid. Carboxylic acid. Sorry. Okay. So carboxyl group still can make hydrogen bonds with water. The carboxylic group can make hydrogen bonds with water. With what hydrogen? This hydrogen is hydrogen bonding. See? It's hydrogen bonding hydrogen. This one. So carboxylic acid can make hydrogen bonds with water, whereas ester can only make dipole interaction. Yeah. Whereas esters, you have to say esters. Is it? Sorry. Ester can make what? Only dipole. Still dipole interaction because it hasn't got a hydrogen bonding hydrogen. No. Hydrogen bonding hydrogen. Present. No hydrogen bonding hydrogen present. Hydrogen bonding hydrogen. Oh. No hydrogen bonding hydrogen present. Is that clear? So then X is more water soluble. Therefore, X is more water soluble in. No, X is more water soluble than Z. Z is ester. All right, that's done. Oh, we have to do one more. Oh, we want two more questions. So I will come back to you soon. Bye bye.